When we create a section in the section wizard, there are two options available to export that to STAAD: Prismatic and General. Same options are available in the user table to create any arbitrary section. Do you know what is the difference between a general and a prismatic section in STAAD and proper usage of these categories? Hi, I am Surajit Ghosh, and in this video, I will talk about the differences between these two types of section and selection of proper category depending on the purpose. Instead, wide range of sections from different catalog are available for steel, aluminum, and timber. Apart from that, we can add different types of user-defined sections for analysis and design using various options. We can define it from the user table. There are multiple shapes and options available to create any type of user-defined section. Also, we can use section wizard, either section builder or free sketch mode, to draw literally any type of section profile or import it from CAD file and export that section to STAAD. Finally, we have few options under the Define tab. From here also, we can create user-defined sections. It is very common that the custom section which we want to use in our STAAD model does not belong to any predefined category. For example, consider a crane girder section, a channel on top of an eye section, or a head section which is used in the core form industry. There is no category available in STAAD to add this type of section, and we can either use the section widget or user table general and prismatic option to handle this section. First, I want to discuss about the user table general and prismatic category. One suggestion: if you want to create an eye section, then don't define it using the general category. We have wide flange and eye section option to create different types of eye section, and it is always better to use these categories for design or optimization purpose. For more details, you can go through my previous video on built-up eye section. General category is used when the section shape does not match with any of these categories, and here we can create the section either by providing the properties or by drawing the shape using profile points. To define a section using property values, we need to specify the cross-sectional area and shear area, moment of inertia, elastic and plastic section modulus. Also, the warping constant value, which is used for the lateral torsional buckling check, is required. Along with these properties, we need to specify few dimensions, and these are not dimension of the actual section or any random value. These are the section dimension of the equivalent eye section. D is the overall depth of the section, B is the width of the flange, TD and TB are the thickness of the web and flange, also the depth of the web. So, to define a general section, we need to first calculate the section properties along with the dimension of the equivalent eye section. This seems like a lot of work, right? But all these dimensions are very important. I will discuss this later. There is another easier way to define any section using profile points. Say we want to create a section like this, and we have the node coordinate values in the x and y axis. If these values are not available, then also we can easily generate these corner nodes from the section dimension. Just use an Excel. We can copy these values directly from the Excel and paste it in this table. See, the section outline is generated based on this node information. Note that all these nodes must be defined in an order, either in the clockwise or anti-clockwise direction, so that it forms a closed shape. And once done, we can click on this Compute Section Properties tab to generate all these properties along with few dimensions. This is easy, right? With the help of section outline and profile points, we can auto-generate the section properties. Also, the CG of the section is internally calculated and corner node coordinates are modified as CG distance. Only problem, TD and TB values are still missing, which are thickness of the web and flange. Now, why this is so important? These values define the equivalent I section dimension, and using these dimensions, program designs any general section as an I section. So we can design any random section as an equivalent I section once all these values are available. Yes, the design will not be accurate as we are not considering the actual section profile or dimension for section classification and capacity calculation. But still we can design it, and design results will be in the conservative side. If the TD and TB values are not available, then program will report a warning message and design will be terminated. Just imagine an I section without the web and flange thickness. Obviously, design of this section is not possible. By the way, these dimensions are required if we design the section using limit state design method, where section classification is a must, like IS 800-2007 or AISC 360 code. If we try to design it using working stress method like AISC AST or IS 800-1984 code, then the equivalent I section dimensions are not required. Only properties are required. Also, it is not possible to use a general section for optimization. Next, we have the prismatic category. Here, the inputs are simple. We need to specify the cross-sectional area and shear area along with the moment of inertia values. YD and ZD are the section dimension, and these values are optional. We can skip this. Under prismatic category, we don't have to specify any equivalent section dimension or detailed properties like section modulus or warping constant, and that's why it is not possible to design any prismatic section. This is the main difference between a general and a prismatic section. If we try to design a prismatic section using any design code like AISC or Indian code, a warning will be reported that prismatic section design is not possible, and we need to define it using user table general category. For prismatic section, only the properties are available which can be used for analysis purpose. During analysis, stiffness matrix is formed for which the inertia and area values are required, which are available. As there is not sufficient information about the section dimension during design using limit state method, program is unable to determine the section class. Hence, design rules will remain unknown and design will be terminated. Why the section classification is a must for any LST code and how this affects the design results, that I will discuss in the next video. To summarize, if we want to design any random section, we need to specify it as general section, where property along with the equivalent I section dimensions are available. General I section design rules are used to design using any design code. But if we want to use the section only for analysis, then we can define it as a prismatic section. It is very easy to define a prismatic section as there is smaller number of inputs. We don't have to calculate the equivalent dimension. So depending on the requirement, whether we want to perform only analysis or analysis plus design, we can select between prismatic and general section. We can follow the same rule when we export any section from the section wizard. We can create any section shape in the section builder mode or in the free sketch mode. I have already discussed this in my previous video. And when we try to export this section to STAAD, there are two options, prismatic and general. If our intention is to design the section, then we need to select the general category. For this, all the section properties are exported along with the equivalent section dimension. These values are internally calculated based on the properties. If we want to calculate it manually, we can use the equivalent section dialog. Here, we can select the type of equivalent section, like a wide flange or I section, specify the bias value, which is used for dimension calculation, and use the Find button. This is the equivalent wide flange section with all section dimensions. Difference between the original and equivalent section is also mentioned in this table. We can use these values during export. I prefer this option rather than the profile points in General User table, as here all dimensions are auto-calculated. For prismatic section, area and inertia of the original section is exported along with a block dimension, same as the user table prismatic category, and we can use this section only for analysis. Finally, there is another general category under Define option. This option has similar inputs like user table general section. Few inputs like section modulus and warping constants are missing, which are required for design using any steel LST code. So it is always better to use the user table general category rather than this general option if we want to design the section properly. That's all from me today. I hope it is now clear to you when to use general section and when to use a prismatic section. Try to use this in your model and let me know your view. Thanks for watching.